Good afternoon, brothers and sisters, boys and girls. Believe it or not, things are pretty quiet out in the solar system as of right now. Well, up until this point, should I say. It is 2:40 p.m. Central Standard Time on December 9th. Once again, we are here at the event map. Please hit pause and write this down. It's actually very simple. It's not a very long one. And you can put this in for yourself and check your local areas and see what's going on. You live over here in England, got a couple of things going on. One of them being some flooding up in the northern parts of England. And well, yeah, I ain't got time to go through all of this and show all this stuff with you guys, but it's definitely a good map to use for around you. I found it from I found a link somewhere and I'm like, holy cow, and so I saved it. And actually I'm glad that I did because it was able to bring me in here to look at the earthquakes that were here on the Cascadia subduction zone. And also we actually had 3 tsunami events that were going on at the same time. So this is definitely something to keep an eye on in your area. Okay? Now, from here, yeah, this is where we're going to have a little bit of fun. Kind of, but not really. I'm going to be doing a second video tonight, and I got to use this, I got to get down on this app a little bit, and I'm really trying to bring together and give more of a better understanding and clarification for flat Earth and round Earth. There's a lot of people that, oh, it's flat, no, it's a crater, and then there's the whole globe, and well, we'll kind of go into that. But right now we are on a PM 2.5 alert. Here we are in China. Where are we by? Oh, Wuhan, right by Wuhan. These two places. That's not good. So, and some of you might have questions about PM 2.5, why it's bad, why it matters. You want to go? Let's go to nitrous dioxide. That's another bad one. Nitrous dioxide. We'll tap that. Bam. Here you go. Over 100. Oh my goodness. And that's just. That is so bad. Oh, look at that. Just, it just keeps getting worse. Just keeps getting worse, folks. Yes, it does. Now, I'm not necessarily picking on the people of Wuhan, but I'm picking on the people of Wuhan just because, well, it's always bad over there. I'm using them as an example, as a perfect example, because, folks, we really need to have the people of China in our prayers. We really do, because as a whole, the Chinese people are actually very good, loving, warm, kind-hearted people. Very welcoming, very considerate, very humble people. It's the government, okay? It's not necessarily them. All of this here, they're being killed. I want you to really understand that. They're being murdered by their government, okay? Over here in India, same thing. That's nitrous dioxide. And the murder, the big die-off hasn't even happened yet. PM 2.5. We've had some very high numbers all over in here too. I'll just move this bugger over here. 68 meters cubed. Let's move it right down here in the red zone. Look at that. 197. Yeah. Now, I have been keeping an eye on this kind of globally to see what's going on. And even though we have some yellow areas, it's not super bad. Yellow, you're kind of over here, but it's still bad enough because there's no such thing as a safe level here in American soil. The Canadian part of America, right over here, it's red. So that's not going to be good for them either. Look at that, 163. Well, I'm going to get into it with you. Let me show you. So here we are at nitrogen dioxide. Nitrogen dioxide is a chemical compound with the formula NO2. It is one of the several nitrogen oxides, is an intermediate in the industrial synthesis of nitric acid, millions of tons of which are produced each year for use primarily in the production of fertilizers. At high temperatures, it is a reddish-brown gas. It can be fatal if inhaled in large quantity. Nitrogen dioxide is a paramagnetic bent molecule with point group symmetry. Now listen, paramagnetic is a form of magnetism whereby some materials are weakly attracted by an externally applied magnetic field and form internal introduced magnetic fields in the direction of applied magnetic field. In contrast with this behavior, diamagnetic materials are repelled by magnetic fields. Wow. So it's magnetic. And our bodies are electric. You wonder why it's not good for our systems? Molecular symmetry. In chemistry, describes the symmetry presents in molecules by the classification of those molecules according to their symmetry. Molecular symmetry is a fundamental concept in chemistry as it can be used to predict or explain many of a molecule's chemical properties. To predict. That's really interesting. So let's come down here to, let's see, where are we at here? Toxicity. Okay. Human-caused sources and exposure, toxicity, health effects of NO2 exposure. Let's just go to toxicity real quick, and then we'll go to the other. Here we go. Diffuses, oh, look at this. It diffuses into the epithelial lining fluid, ELF. That's kind of funny. That rhymes exactly with, these three letters are also used for extreme low frequency, as in Schumann resonance, of the respiratory epithelium and dissolves. It chemically reacts with antioxidant and lipid molecules in the ELF. The health effects of NO2 are caused by the reaction products of metabolites. Well, yeah, basically, hit pause and read this. I'm not going to go through the whole thing. But you come down here and it kind of gives you all the parts per million. And what it does, look at this. Irritation of the nose and throat, 250-500, can cause edema, leading to bronchitis and pneumonia. Kind of like jibbity jabbity corona breedy. You know, the Corona beer. Corona, the sun has a corona, the coronal holes. And levels of 1,000 parts per million can cause death due to asphyxiation from fluid in the lungs. There are often no symptoms at the time of exposure other than transient cough, fatigue, and nausea, but over hours, inflammation in the lungs causes edema. Yeah, basically, it can and will kill you, and it also leaves you hypersensitive to magnetism. Well, that's interesting. Now, PM 2.5. Now, the reason it's PM 2.5 is that's the how small the molecules are. 2.5. It's like microns. It's like super, super inky dinky small. Like literally, particular matter. PM 2.5. It's super small. So you can come here. It says when we burn fossil fuels or production, energy, or mobility, it generates chemicals and gases and pollute air. So we know that it comes. This thoroughly invisible to the naked eye. You're not going to see this. You're not going to see PM 2.5. Look at this. It's made up of chemicals, allergens, dust, smoke, or soil. Well, how does it get to the soil? Acid rain. Well, where does the acid rain come from? From the production of all that bull crap. Go ahead and hit pause here, and you can give this a good go over to look at. It's really something that everybody should look at. I'm not even joking. This is very important. 2.5. It refers to the size of the pollutant in micrometers. Okay, the tiniest thing which the human eye can see is at least 0.1 millimeters. About the width of the hand of a fine hair, 70 microns. So this is micrometers. I mean, this is super small. 2.5. You're not going to see it. Depending on how healthy a person is, fine particulate matter will have a various short-term and long-term health impacts of inhaling PM 2.5, especially PM 2.5 smoke. If you're exposed to the levels between unhealthy and sensitive groups, AQI 100 to hazardous 300 plus, you might experience one or more of the followings. Yeah, this is where we get to the fun stuff. Not really. Asthma, lower heart function, possibility of a heart attack, reduced lung function, acceleration lung function, wheezing, coughing, throat, nose or eye irritation, shortness of breath. Yeah. Now, where do a lot of these things come from? Can anybody else guess? Besides fertilizer, where does PM 2.5, a large deposit of? Red iron oxide. Yes. Where does that come from? Yeah. So we're not only producing it, it's also we're going through it. So yeah. So when you see me over there and I'm doing these alerts, it's not something to be like, oh yeah, no, it'll be fine. No, it's not fine. It's something to take very seriously. So please be careful and understand there's a lot of things that are going on here that are not good for anybody. And this is, do you see what they're trying to push? Wear your mask, wear your masks. They actually have them in 2.5 filters. But guess what? It's still not going to stop you from the virus that doesn't exist, that we made up. So, something else we got to look at. Now I'm actually going to switch gears on you. come over here to, there's really nothing going on. No bursts of anything except for one little thing. I want everybody to take a look at the time here. 10:06. Okay? Boom. Very next image. 12 minutes later exactly. This thing shows up. Okay? And then what? Now, you're going to notice that this actually does move. The screen does actually advance. Watch this right here. You'll actually see it shrink. See that? But this doesn't move, and this shows up. So this stays there. Oh, it's still there. And then we got a Borg cube, but I think he threw it on the wrong side. Ding dong. And then it's gone. Isn't that interesting? So what is that? Let's see here. 1, 2, 3 frames. And it doesn't move. Gotta make you wonder. And this right here is a little update. This is called Solar System Scope. I'm actually going to be putting together a little presentation on my take on flat Earth versus globe Earth versus crater Earth. And I'm going to be using this particular... Oh, it does have music, by the way. I'm actually going to be using this particular model because it really does a lot to kind of help you understand about when you're at the South Pole and you're looking down and seeing those constellations versus being at the North Pole and looking up and seeing those constellations. Well, I guess you're looking up either way, but you know, you get the drift. So, yeah, it makes a big difference on and that's just kind of one of the things. If you were on a flat plane of existence, no matter what, because if you're at the South Pole over here, well, I'll do the presentation, but this is one of the tools I'm going to be using, and actually it is a really nice tool. I mean, they do a really good job. You can zoom in, zoom out. Oh, come on now. Oh, geez, sure, now it's going to act all wonky on me. See, there we go. I mean, we can keep on going out. And it goes all the way to you can go all the way out in the Milky Way and zoom in on it. So, yeah, I'm going to play with this a little bit later. And I'm going to do a presentation on it and kind of give you guys my take on it. But you guys have a good one. Be safe. And please be careful and keep an eye on your areas yourself so that way you're kind of informed for yourself and for your families and friends. All right? Love you guys. Be safe. Please like, share, and subscribe. Love is the only way forward.